Tools of the trade. www.asyrani.com. Revamped by Dr. Ilkachandani Pendit. How to write your own game engine. Which language? C++. 2. What do you have to learn from C++? Classes, methods, inheritance, polymorphism, and encapsulation. How to write your own game engine. 2. Which API? To write your renderer. Either Fukan or DirectX 13. But, if you are writing API code for the first time, start with OpenGL. Why? Many resources and tutorials. To have basic engine loop. And build rendering interface abstraction later. Create context for any graphic API. Games which are built or used OpenGL. 1. Baldur's Gate 2, Shadows of Amn. 2. Brink. 3. City of Heroes. 4. Call of Duty. 6. Counter-Strike. 7. Doom 3. 8. Doom 3, Resurrection of Evil. 9. Doom. 10. Enemy Territory, Quake Wars. Games which are built or used OpenGL. 11. Far Cry. 12. Half-Life. 13. Hitman. 14. Left 4 Dead. 15. Neverwinter Nights. 16. Portal. 17. Penumbra. 18. Star Wars, Knights of the Old Republic. 19. Star Wars, Knights of the Old Republic 2, The Sith Lords. 20. Star Wars, Jedi Knight, Jedi Academy. Games which are built or used OpenGL. 21. Star Wars, Jedi Knight 2, Jedi Outcast. 22. The Chronicles of Riddick, Escape from Butcher Bay. 23. Unreal Tournament. 24. Unreal Tournament 2004. 25. World of Warcraft. So, yeah. OpenGL is legit, guys. So, let's start off with C++. If you are not fit in C++, please go through C++ series by Cherno. https://www.youtube.com/watch?v=183mtx0pk0 &list=PLL Then, next. OpenGL. https://www.youtube.com/watch?v=. Learn how to render characters, how to rotate and translate characters, how texturing and lighting works. But, what is OpenGL, anyway? It's an API for drawing graphics. The whole purpose of OpenGL is to transfer data from the CPU to the GPU. Once data is in the GPU, it is processed by the OpenGL rendering pipeline. The rendering pipeline processes the data through several stages known as per-vertex operation, primitive assembly, primitive processing, rasterization, fragment processing, per-fragment operation. Per-vertex operation. First stage. Vertices are processed by a shader, known as the vertex shader. Each vertex is multiplied with a transformation matrix, effectively changing its 3D coordinate system to a new coordinate system. Just like a photographic camera transforms a 3D scenery into a 2D photograph. The vertex shader changes the 3D coordinate system of a cube into a projective coordinate system. Next. Goes to primitive assembly. After 3 vertices have been processed by the vertex shader, they go to primitive assembly stage, where a primitive is constructed by connecting the vertices in a specified order. Next is primitive processing. Before the primitive is taken to the next stage, clipping occurs. Any primitive that falls outside the view volume, i.e. outside the screen, is clipped and ignored in the next stage. Next Rasterization. Pixels approximating the shape of a primitive. This approximation occurs in the rasterization stage. Pixels are tested to see if they are inside the primitive's perimeter. If they are not, they are discarded. If they are within the primitive, they are taken to the next stage. The set of pixels that pass the test is called a fragment. Fragment processing. A fragment is a set of pixels approximating the shape of a primitive. When a fragment leaves the rasterization stage, it is taken to the per-fragment stage, where it is received by a shader. This shader is called a fragment shader. Apply color or texture to the pixels within the fragment. Per-fragment operation. Finally, fragments are submitted to several tests like pixel ownership test, scissor test, alpha test, stencil test, depth test. At the end of the pipeline, the pixels are saved in a frame buffer, more specifically the default frame buffer. These are the pixels that you see in your screen. The figure below shows how frame buffer works. Next, I will explain some OpenGL codings in your Lab 1 module to you. Understanding OpenGL objects. Glenable, enable or disable server-side GL capabilities. GL_depth_test, if enabled, do depth comparisons and update the depth buffer. GL_color_material, if enabled, have one or more material parameters track the current color. GL_lighting, if enabled, use the current lighting parameters to compute the vertex color or index. If disabled, associate the current color or index with each vertex. GL_light, if enabled, include light in the evaluation of the lighting equation. GL_normalize, if enabled, normal vectors specified with GL_normal are scaled to unit length after transformation. 1 GL viewport function sets the viewport, the x, y, width, and height. 2 GL matrix mode function specifies which matrix is the current matrix. 3 GL load identity function replaces the current matrix with the identity matrix. 4 GL perspective function sets up a perspective projection matrix. GL load identity function replaces the current matrix with the identity matrix. GL normal set the current normal vector. For more OpenGL coding, please refer to https://docs.microsoft.com/n-a/windows. Next, beside OpenGL, you will also use Visual Studio C++. Visual Studio Introduction. VS is an integrated development environment, IDE. Includes powerful text editor, source level and machine level debugger. Many more. Source files, headers, and translation units. A program written in C++ comprised of source files. File extension equals .c, .cc, .cxx, or .cpp. Source files equals translation units. Special source file equals header file. Header files exists as distinct files from the point of view of the programmer. Libraries, executables, dynamic link libraries. Object file, .obj. Relocatable, memory addresses at which the code resides have not yet been determined. Unlinked, any external resources references to functions and global data that are defined outside the translation unit have not yet been resolved. Linker jobs. To calculate the final relative addresses of all the machine code. To ensure that all external references to functions and global data